Hi, I'm Brian Buffing with Ecowater of Athens Metro Water Filter, and I'm here at the home of Hugh and Jenny Walton. We're going to take a look at the water in their home and see if there's anything that they would like to eliminate to either save them money or make it healthier. And so what I'm going to share with you today is what I do when we test water and why you might want to do the same thing. We're going to start with the water coming out of the kitchen faucet, and we're going to run it through this, which is a miniature refiner. It's a small version of what we put in folks' homes. It has two parts to it. It has some tiny little orange beads called resin that pulls out the minerals in the water, calcium, magnesium, those kind of things. It also has some black particles, which is activated carbon, very similar to what's in your refrigerator filter or a Brita pitcher or something like that. The difference is this is made from coconut shells. It will last forever as long as it's backwashed. This will continue to pull out chemicals in your water like chlorine, fluoride, plus all the pharmaceuticals and things that get dumped down the drain that aren't there on purpose. Those are pulled out, as well as the things that are put there on purpose. But we're going to hook this up and run the water through it. We're going to test the water coming from the faucet, and we're going to compare that to the water coming through the miniature filter. All right, the first thing we're going to look for is minerals in the water hardness as opposed to soft water. When most folks think of hard water versus soft water, it sounds like you're adding something to the water to make it soft. What you're actually doing chemically is removing stuff from it to make it soft. So by pulling the minerals out, you go to soft water. Now you can chemically treat water and make it appear as if it were soft water by making it behave as soft water does, but that's not really what we're doing. We're actually pulling the minerals out to make it soft water. So we're going to take a very small sample of water, and we're going to add it to this little vial here, and we're going to add a couple of things to it to test the hardness of the water. It's pretty simple. The first thing we use is a hardness solution number 1, and what this basically does is it bonds to any of the minerals that's actually in the water. And while it's still fairly a mostly clear yellowish liquid, doesn't really show anything up, the second thing that I add to it actually is an indicator to tell me whether I have minerals in the water or not. If there's no minerals in the water, it will turn blue. You'll actually see it turn a blue or purple color initially, but as it mixes in, it turns kind of a reddish or purple or pink color. That means that there's minerals present in the water. I'm just going to add 3 drops to this. And as that mixes in, it turns more of a red color than the blue. The third thing I want to add is a indicator. This is actually a chemical water softener. It's very similar to what you'll see in Cascade or detergents, those kind of things, that makes the water behave as if it were soft. So what this will do is it will turn it back blue. Don't really know how many drops it's going to take to turn it blue. If the water is severely hard, it could be 15, 20 drops. If it's just barely, it could be 1 or 2 drops. So it will make the minerals in here behave as if they're not there, just like it does in the washing powders or those kind of things. So we have 1, 2, 3, and we're at purple, and 1 more, and we should be kind of this royal blue color. So what that means is you have 4 grains per gallon of dissolved minerals in your water. Not many people measure things in grains. You think maybe sand or salt or something like that, but if you look at a bottle of aspirin, aspirin tablet is 5 grains. It actually says so right there on the bottle. So you have about 80% of an aspirin tablet of dissolved minerals in every gallon of water that flows through your pipes, your plumbing, your water heater, all those kind of things. So if you were to take an aspirin, cut off just a little bit of it, dissolve it in there, that's about how many minerals you have. So that doesn't sound like a lot to most folks, but the average person uses about 500 gallons of water a week. A dishwasher, washing machine is like having another person. So it's like having somewhere in the neighborhood of about 1,200 aspirin tablets a week of dissolved minerals that's going through your dishwasher, washing machine, water heater, those kind of things. So over time that builds up. That's why if you ever had to replace a shower head because it's not flowing like it used to, if you ever had to replace a hot water heater because stuff is built up in it and you have all kinds of junk when you wash it out, that's from the minerals that's in the water. So it actually would save you a lot of money to pull that stuff out before it goes through any of those water using appliances. That's the biggest thing. We'll talk a little bit more about water hardness and what that does with some other things, your laundry, in just a few moments. Okay, next thing we're going to look at is chlorine in the water. If anybody has a pool or a hot tub, they're probably familiar with this. This is basically just a chlorine tester. It indicates how much chlorine is in the water. We're going to use the same kind of thing to test for chlorine in the water from the sink. So we're going to add a little water to this side. And we're going to do the same thing. This is a chlorine indicator. We're going to add it to this over here. And basically, however dark the water gets as far as yellow, that tells you how much chlorine is in the water. We're going to compare it to this little chart here. That looks like about 1.5 parts per million. If I look about that color, matching that up. If you can see that, don't know if you can, but that 1.5 parts per million is about the same darkness of the yellow. What that indicates is that's how many parts per million of chlorine is in the water. Again, this is a pool tester, and on the side of it there, it reads ideal. Can you see that? So that means it has a perfect amount of chlorine for the water. That's the perfect amount of chlorine for a swimming pool, because it's a swimming pool tester. So what's essentially coming out of the tap is the perfect amount of chlorine for filling up a swimming pool. You wouldn't have to add anything else to it, and you got pool water. If you probably wouldn't go to your neighbor's house and get a cup of pool water and drink it, but essentially that's about as much chlorine as what you've got. Chlorine is a necessary evil. It's got to be there. Millions of people would die every year from dysentery and all kinds of other nasty diseases if the chlorine wasn't there. But the ideal thing for it to happen is for the chlorine to be in the water all the way up until you get to your house, and before you use it to shower in or drink, it be pulled out, because there's some great things about pulling that out before you do any of those kind of things. And we'll talk more about that in just a couple of minutes. All right, next thing we're going to do is we're going to get some water in this bowl right from the sink, and these are Miss Jenny's bowls. And we're going to take the water, and this is not a magic trick. I'm not adding anything to it. We're just going to split that up a little bit. Let's get a little bit more. And he'll let you be the guinea pig today. Pick one of them, doesn't matter which one, and just put your hand in it. About 30, 45 seconds. Put your whole hand in it. All right? He picked the one on his left. All right, I'm going to put a few drops of chlorine indicator in that bowl. I didn't add chlorine. Chlorine's already there. So what this means is that, again, the darker it gets, the more chlorine is in the water. And that's getting pretty yellow there, as you can see with the through the clear bowl. And we'll let that sit there for just a second. I'll get a couple of paper towels here for you. Maybe about 20, 30 seconds there. That should be good. All right, we're going to do the same thing. I'm going to put 6 drops on this other side. Again, this is an indicator. It tells us whether there's chlorine in there or not. And on the other side, that's a pretty light yellow color. There's still a little bit of chlorine in there, but it's not what this bowl is, which is almost orange at this point. What that means is that this bowl doesn't have any chlorine in it, or not near.
Full of chlorine.
Right. In that 30 seconds or so, you absorb just about all the chlorine out of that bowl, where this one still has all the chlorine in it. So what that means is that people get real concerned about pulling the chlorine out of the water they're drinking, but they don't even think about in the shower, they're actually going to absorb more in a 10-minute shower than drinking a gallon of chlorinated water. So you buy bottled water or buy a Brita pitcher, get it through the refrigerator, thinking that's going to be healthier for you, but the chlorine in your body, pulling your body, is actually, you're more in danger from that in the shower than you are drinking it. The next thing we do is take a look at whether there's any iron, or see if the pH in the water is healthy or not. If you are talking about pH is on a scale of 0 to 14. Soap, those kind of things are typically pH is high, 9, 10. Baking soda is in that range. Acidic water is around 4. Battery acid or lemon juice is around 2. Battery acid is 0. Neutral pH is 7. So you're talking about water that wouldn't have a bitter taste and would be healthy as far as that goes. That's what we're looking at, is pH right around 7. Basically, the way we test for pH is we have 3 or 4 different ways. My preferred method is we have this dark green pH solution. If the water is neutral, you add it to water, it's just going to dilute it. It's going to be kind of a light green color. That's the simplest way to explain it. If the pH is higher, it's going to stay that dark green. If it turns yellow or orange, it means the water is low pH. Now, we mentioned that from a health standpoint, 7 is about where you want it. But when I test for water, yes, health is part of it. But what we're really looking at is cost issues. If the water is very acidic, then your plumbing, anything metallic is going to be in danger of getting pinholes, those kind of things in it, especially copper plumbing. But if anyone has really any plumbing at all, it eventually all goes through a metal faucet. It goes to the back of a refrigerator, back of a dishwasher, back of a water heater. All those things are metal. If the water is acidic, eventually it's going to eat away at that, either put that metal into the water or put pinholes in that plumbing. The worst possible combination is copper plumbing and acidic water, because then you have thousands of dollars to replace that type of plumbing. Today we're looking at city water, and I don't know that we're going to have an issue with the pH, but it's something we test for every single time anyway. The other thing we test for with the same indicator is iron, and we look at that. We have a indicator packet that we'll add to this side. If it turns orange, we have iron in the water. If it stays clear, that means we don't. So we'll place the pH solution in here. In the iron packet. Go on the other side. Find all my toys here. And what we have is the water on this side with the iron is fairly clear. There's nothing really in there. There's no iron to speak of in the water. Iron is not necessarily a health concern, but it's definitely a cost concern. It's very much an irritant, and it will definitely damage clothes and washing machines and those kind of things. The other side, the pH, it looks like it's right at that 7, which means that we're good as far as the pH goes. So it's not, we don't always find problems every time we test for water.